In this question, they give you the polynomials, and then they say that when this polynomial divided by x minus 2, then the remainder is negative 33. So we learn it when the function divided by x minus 2, then the remainder is equal to negative 33 here. And very important thing is, by the remainder theorem, we can express the remainder, which is equal to f, put a suitable x inside. What is suitable x is when the divisor becomes 0. So when x is equal to 2, the remainder is equal to negative 33 is what they want to tell you. If you forget why the remainder theory works, then you better find relevant information. But at this moment, remember that the theory tells you a shortcut method to find out the remainder is to substitute a suitable value of x to make the divisor become 0, so that only the remainder term is left. So if we follow this calculation, because we have the original function, that's why we just replace x by 2. Therefore, we have an equation with only c be the unknown. Then we can solve c afterward. After we get c, we substitute it back to the original function. That means we have the full function. Then we can handle the remainder when fx is divided by x plus 1. And then we can check whether it is a factor or not. Anyway, we focus here first. We get c is equal to negative 9. So therefore, fx is equal to 4x power 3 minus 5x squared minus 15x and then minus 9. And we want to know, is that a factor? That means we are asking when fx divided by x plus 1 is remainder equal to 0 or not. So we consider when fx divided by x plus 1, the remainder is equal to f. By remainder theorem, again, put a suitable x to make the divisor become 0. That's why we choose negative 1 in this case. Again, replace x by negative 1 and then calculate it carefully. So we get 0, which means that the remainder is 0. We can write down since f negative 1 equal to 0, therefore x plus 1 is one of the factors. Then we finish part A and we proceed to part B. In part B, they ask us to solve fx equal to 0, and then we are going to check those roots. That means the result is that all rational numbers. So we just write down the original function, 4x power 3 minus 5x squared minus 18x minus 9 equal to 0. Don't forget that they try to lead us to show that x plus 1 is a factor, which means that this expression can be expressed in x plus 1 times something. How can you find out that something? It seems like I'm asking you 3 times something will give you 12. Then in your brain you're talking about that something is 12 divided by 3. So we are going to use the long division. We use the original function divided by one of our factor, so we can get other factor from the quotient. So to perform this, we just look at the first one, 4x power 3 divided by x, so we have 4x power 2. And then the second step is 4x squared times the divisor, so we have 4x power 3 and positive 4x squared. After that, we use this part to minus this part to calculate the remaining part. Therefore, we have negative 9x squared. We finish one cycle, we just repeat the same cycle afterward. Negative 9x squared divided by x gives you negative 9x. And then negative 9x times the divisor, we have negative 9x squared, negative 9x. We use negative 18x minus negative 9x, therefore we have negative 9x left. The last cycle, negative 9x divided by x, negative 9 is left. So this is negative 9x minus 9, so therefore we have no remainder, which is consistent with our conclusion that x plus 1 is factor. So we have 4x squared minus 9x minus 9 equal to 0. We successfully write down that something times something equals 0. So by the zero product rule, either the first factor is 0 or the second factor will equal to 0. So x is equal to negative 1, and then this polynomial from power of 3 downgraded to power of 2, which is quadratic. Then we know how to solve it. You may use quadratic formula in your calculator, formula 1, or you may use cross method to factorize it. If you factorize it, you get 4x times 1x, and then we have minus 3 times 4, and then together with positive 3 here. So 4x plus 3 equal to 0, or x minus 3 equal to 0. Another zero product rule. X is negative 3 over 4, or x is equal to 3. If you use calculator, then from here, by using formula 01, you will jump directly to this conclusion. And then we are going to check 1, 2, 3, 3 roots here, are they rational? That means, is that able to write using integer to write down a fraction? So this is rational, this is rational, this is rational. So we agree the claim. All roots are rational. Therefore, agree the claim. And one thing very important about rational number. Some rational number like 2 over 3 is rational. Irrational. It seems like, for example, like square root 2, you can't use fraction to express it. Or pi something, you can't use a fraction to express it.